All right, here we go. Hi. So today we're going to work on multiplying and dividing. I want to start at the top by just letting you know there is a lot of words on this paper, right? There are a lot of sections. I actually typed out a bunch of stuff so that you would have less writing to do. And then I realized if you don't have a printer, that's not that helpful. So do want you to take college style notes, write down what seems important to you, because not everything has to be written down. Write down the things that are important. You do have access to the notes themselves, so you can always refer back to the notes. So I just want you to write down what you think is important. I personally think definitions and examples are usually the most important part. So take that with a grain of salt. Use that if you will. But we are going to jump into multiplying and dividing. Where we've been, right? Last week we did simplifying. We did adding and subtracting if they were like terms like radicals. And today we are going to multiply and divide, right? So, from what you remember last week, or like in your life in the past, are we allowed to combine 3x plus 5x squared, or is this the most simple that it could possibly be? Gally says no, we're not allowed. Everybody agrees with Gally. Anyone disagree? Okay, cool. So we are not allowed. OMG, I totally forgot. My friends, you should have breakout rooms available to you. I forgot to make this announcement. If you want to watch the video, you're welcome to. I recorded the video. It is available to you on Canvas as well as on this little like notes link right here. We'll let you. So I will let you jump in. You should have a breakout room button at the bottom of your Zoom screen. You can go ahead and press that button. If you don't see it and you want me to transfer you, I can transfer you, but feel free to jump into a breakout room if you would prefer to watch the video. That is totally fine. I won't be offended. Cool. Okay. So we are not allowed to add and subtract. They are not like terms, right? They're not like terms. There's nothing we can do about it. Are we allowed to multiply and divide these items? Can we do it? Can we multiply and divide them? Yeah, thanks for those direct messages. Thanks for the public messages. Yes, we can. We can multiply and divide them. If I was going to multiply these together, I would do 3 times 5 would be 15. And then I have x times x squared, which we already know is x times x already. So I have x times x times x would be x to the third power. Cool. Easy peasy. If we have 3x divided by 5x squared, not much we can do with 3 over 5. That is already simplified. But x over x squared, as we remember, is x times x. X divided by x would cancel or equal 1. So this would simplify to 3 over 5x. If you're with me, give me that thumbs up reaction bar. You're like, yes, miss, I remember these things. You've got a reaction button. I've got 10 thumbs up. I love it. Sweet. Got 16 thumbs up. Big facts. Cool. Awesome. Okay. So the big idea when we're thinking about radicals is that 3 square root 2 and 5 radical 10 also can't be added or subtracted, right? As we remember from last week, they can't be combined with addition or subtraction because they are not like terms. However, they can be multiplied and divided. And what we're going to do in order to multiply and divide them is we're going to multiply outsides with outsides and insides with insides. Outsides with outsides, insides with insides. So what I mean by outsides and outsides, we're going to take the coefficients and we're going to multiply them together. That's why you see 3 and 5 on the outside here. Right? And then we can do insides with insides. So radicands with radicands. So the number 2 and the radical 10, we can multiply those together here. So that means that we have 3 times 5 would be 15. Those are our outsides coming together. And we have 2 times 10 is our 20. Those are our radicands coming together. So we have this one here, and then we need to simplify, which as you remember from last week, you have a couple options. One, you can do 20 and you can like split it up and say like, okay, it's 4 and 5, and then 4 is 2 and 2. And you're like, okay, I made a group here, so that comes to the outside. Or you can remember that if we have 4 and 5, this is like the radical of 4 and the radical of 5. The square root of 4 is 2, so that 2 is coming to the outside here. And then radical 5 is staying on the inside. It does not have a pair to get out. Right? So then we know that this simplifies to 30 radical 5. Since I saw 94% of us were doing just fine on Thursday, I'm not going to spend too much time thinking about the simplification process. The big idea here for this is that we're going to do outsides with outsides, insides with insides, right? So coefficients, those are our green numbers, radicands, those are our yellow numbers here. I want you to go ahead. I have 3 examples on the screen, right? 3 examples on the screen. Using the one that we just went through, using our big idea, I want you to go ahead and try as many of these 3 as you can in the next 1 minute, right? So 1 minute, try these. Let me know if you have finished all 3. Take 1 minute, try these examples. Go. All right. Been about 1 minute. Thank you to those people who let me know you were ready. For those of you who are trying to type the square root, I don't know what the shortcut is for either one. If someone wants to look up the shortcut for Mac or PC for typing square root, I only do it on the equation editor, so I don't usually do it in the chat. It might be, no, I don't know what it is. So if someone wants to look it up, that'd be awesome. While we plug in these examples. So for this one here, we have 2 times 3, that's 6, root 50. Notice what I'm going to do here. I'm going to do 5 times 10, but I'm going to break up 10 into 5 times 5, or sorry, 5 times 2, right? So I have this original 5 is here, and then I broke up 10 into 5 and 2. I don't need to go through the process of multiplying 5 times 10, getting 50, and then breaking 50 down again, right? I already have 5 and 10. I already have 5 and 10 as my 2 numbers. And so now I can say, okay, well, this is a group of 5s that can move to the outside like that, right? So 6 times that 5 would be 30. Root 2 is left over. There is no pattern for 2, right? So you have 30 square root 2. We have some friends in the chat who are helping us. Alt V for Mac. If you have, oh yeah, look, I can do it on my MacBook. Nice. So, and then Devin said for Windows, you hold down Alt and you type 251. I'll put this in the chat so you can try that. Go ahead and send me a square root. For me personally, sometimes what I do when I can't find it is I highlight one that's already been done on the computer and then I copy it and paste it and see if it works. Yeah, nice. Devin's got it. Galley's got it. Option V. So Alt or Option V if you're on a MacBook. Cool. Now you can type all kinds of square roots. Sweet. Thank you, team. Cool. So same thing for this one here. I maybe wanted to highlight that there is a coefficient of 1 here. So if you're all like, wait, what do I do? What's the outside number there? Coefficient is 1 times 2 would be 2. And then you have 6 times 3. Remember 6, instead of 6, I can write 2 times 3. That's a more helpful version of that. And so then these 3's can go to the outside here. So I would have 6 square root 2. 6 square root 2 for that second answer there. For my third option, I have, our third example, I have negative 2 times 5, negative 10. 6, a more helpful version of 6 is 2 times 3. I have 15. A more helpful version of 15 is 3 times 5. All right, so you can see I have 6 here and 15 here. I have a pair of 3's. So those 3's can move to the outside. I have negative 30 now as my coefficient. And then 2 times 5, putting back together to be 10, like so. So I should have that as my answer there. Give me a thumbs up if you're feeling good about this. Give me a thumbs down if you're feeling bad about this. Give me a like shocked emoji if you're feeling like, whoa, I don't know what to do about this. I've got some thumbs ups. I got one shocked emoji. 50 out of 50. Got some more thumbs up. Appreciate you. Cool. All right, team. Okay, so for our distributive property examples, I'm going to do 2 of them. If you need to see more, then I will absolutely do some more. But I think we're gonna get it after this. So I'm going to do these first 2 here. So if you're in the process of writing down problems, I'm going to do this one here. I'll leave this one on the screen so that you can see it. Make it a little bit bigger. Cool. So with distributive property, if we had a number outside, as you know, we're going to distribute into each of these pieces here. All right, so I'm going to take my 3 root 3, multiply times 4 root 8, and then multiply 3 root 3 times 5 root 2. So I'm going to do 3 times 4 would be 12, and then 3 times 8 would be 24. I'm going to do the second one times this one here. So minus 3 times 5 would be 15 coefficients. Radicands 3 times 2 would be 6 for my new radicand. 6 I know is only 3 and 2, cannot be simplified. However, 24, I know that 24 is 4 times 6. The radical of 4 is 2. So I know this is going to be moving to the outside. So 12 times 2 would be 24. And I'm leaving 6 inside. Bringing this straight down here. Right, so I simplified 24 into 2 root 6. That 2 times the 12 makes 24. 24 root 6 minus 15 root 6. Can I combine these now? Am I allowed to combine them? Or should I leave them separate? Yeah, lots of people saying yes, I can. So I have 24 of them minus 15 of them would give me 9 root 6. 9 root 6 as my answer there. Cool. Let me get a gauge. How are we feeling so far? Fist of 5. Tell me in the chat. Not in the chat. Tell me in the poll. Tell me in the poll. How are we doing?
Another way you can do it is to simplify the 4 root 8. So if you use what Ms. Mack taught us earlier, root 8 can be simplified to root 4 times 2, which we know root 4 is 2. So you get 4 times 2 root 2, and you'll get 8 root 2. So that's a faster way of approaching it too.
Absolutely. Thanks, Ms. Yamanaka. Right. So one thing, so math, as always, has many ways that you can do these problems. If you were to simplify 8 root 2 in here, right? If you were to simplify beforehand, yeah, then that becomes a more simple process, right? Because now, let me erase this part. Now, instead of 4 root 8, you have 8 root 2 times 3 root 3. Right now, you're going to go straight to your 24 root 6, right? Absolutely. You are going to, so if you simplify before, it could make it an easier question. Thanks, Ms. Yamanaka. That's awesome. Any other ways that people are saying to do this? I don't want to cut us off in our multi-brains. Okay. Feel free to jump in if you see another way. All right, let's try this one. This looks a little scary. What do you see here? What does this look like? So I have binomial times binomial here. What do you see? Any ideas on how we could think about this one? Box or X, yeah. Lots of people saying box here. You can totally use box. If you know FOIL, right? If you know FOIL, you can FOIL if you want. I think we here at Hybrid High are usually more familiar with box method. Notice I'm making a normal or a bigger than normal size box. I know lots of us try to do these little baby boxes with radicals because you're going to have 2 parts. I would recommend bigger boxes. So I have square root of 7. I have 2 root 3. I have 2 root 7 and negative square root 3. I'm going to go ahead and give you a moment to either write this down or try filling in these boxes if you are feeling confident. Jump in. All right. Remember, this is a 1 here. So 2 times 1 would be 2, right? And then square root of 7 times square root of 7. What is the square root of 7 times the square root of 7? Nothing. They cancel? I'm seeing other 7s coming through. I have the square root of 7 times the square root of 7 would be square root of 49. And the square root of 49 is just 7. Absolutely, right? It's just 7. So anytime that we see the square root times its own square root, it's just going to be that number, right? So I have my original 1 times 2 would be 2, and now I have another 7. So 2 times 7 would be 14, ends up in this box, right? 14. So I'm doing square root of 7 times 2 root 7. Now I'm doing 2 root 3 times 2 root 7. This here would be 4 root 21. Does 21 simplify? Is there anything we can pull, any perfect squares we can pull out of there? Walter says no. I'm going with Walter. Awesome. I have negative, remember this would be like -1 here. -1 is my coefficient. So -1 times -1 would be negative. And I have 3 times 7 root 21. We already did 21. Walter said no, so I'm going with Walter. And then I have positive 2 times -1 would be -2, right? -2 times square root of 3 times square root of 3. What did we say? Square root of each other times itself? What would that give us? Square root of 3 times square root of 3. 3. Yes, Galilee, thank you. 3. So I'd have that -2 from the coefficients times the positive 3 would be -6. -6. If it is helpful to you, this is why I like the big box. If it is helpful to you to think in steps, sometimes I use like little numbers here. Maybe if you've ever played Sudoku, kind of like that, right? So like where you use like little numbers to remember your hints, and then you could, when you decide on an answer, you can write your big answer there. So what, if any, like terms do I have here? What, if any, like terms do I have? The square root of 21s are like terms for sure. Any other like terms? Yeah, 14 and 6, 14 and negative 6, right? So 14 minus 6, that will give me 8. And I have 4 root 21 minus 1 root 21 would be 3 root 21. It's positive, so I'm going to put a plus sign there. This would be my answer for this type of problem. This is my answer here. I cannot combine them any further because even though 8 and the positive number 3 are like terms, this is 3 root 21, 3 times root 21. So this is the, like, you can think of it like this is saying 8 plus 3x, right? We can't combine those because those are not like terms. This is a similar situation here. We have 3 times a number. It's not just 3 times, they're 3 by itself, but 3 times that number. Cool. All right, how are we feeling? Wow, I'm never ended that poll. Oh, we were feeling good. Okay, one more time. Tell me, how are we feeling thus far? Threes, fours, fives. Cool. I'm gonna actually end this poll this time. We have mostly fives and fours, some threes, totally fine. Cool. Okay, in the interest of time, I'm gonna have us jump. I am actually going to, let me do this. I'm gonna walk us through, I'm gonna talk through these problems. I don't want you to write anything down unless it feels like super necessary. I want most of your brain juices to be focusing on what I'm saying, right? So don't try to, I know some of us are like obsessive note takers. You're just like trying to write down everything. If you're that type of person, you can go back to the video after class. However, for right now, I want us to just focus through. I'm going to talk through this portion here. I'm going to talk through this portion here. And then we're going to work through this portion here. And I want us to do these before we go, right? That's why I want us to talk through this portion and not write it down, because I'm going to go a little faster than I would normally go if we were taking notes. Okay. Capiche? Capiche. Cool. All right. So the decimal equivalent of the square root of 12 is 3.464 da 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 da. It goes on forever and ever and ever. This is called an irrational number. An irrational number, as you guys probably remember, is a number, is a decimal number that goes on and on forever. It never repeats itself. Also like pi. Pi is also an irrational number, right? The decimal equivalent of square root of 16 is 4. It's a whole number, right? This is a rational number. Rational numbers meaning any decimal that ends or any whole number. So 1/2 is also a rational number. Rational also means fraction, right? You cannot represent this as a fraction. And so that is why it is irrational. So you have to think back to like before we had calculators, right? Before we had calculators, it was very, very challenging to divide by a decimal, right? So if you had 2 over 2.543, that is a much harder problem than say 2.543 divided by 2. So before we had calculators, what you really, really wanted to do was to get your decimal to be in the numerator and a whole number in the denominator, because it's much easier to divide. You would want to do this thing. So there is this process called rationalizing the denominator, right? To rationalize something means to make that thing rational. We don't want a radical. We don't want this square root to be in the denominator. So the process that they came up with, or mathematicians of old, right, our mathematician ancestors, was to multiply the numerator and the denominator by that same rational, by that same radical that is in the denominator, and that's going to rationalize the denominator. So here's what I mean. If I start with this number here, 3 over square root 2. If I multiply times square root of 2 over square root of 2, Then what's going to happen when I multiply, as we just talked about, square root of 2 times square root of 2, that's going to give me the whole number 2 on the bottom, right? I have 3 times the square root of 2 is going to be 3 square root of 2 on the top, right? This is much easier to calculate, like to get a decimal equivalent than this was, right? I don't want to divide by square root of 2. I'm happy to divide by 2. I don't want to divide by square root of 2. You'll notice if I type this into my calculator and get a decimal, it will be the exact same decimal as if I plug it in, right? The reason why it says, why does this process not change the value of the expression? Why? Because when you multiply times square root of 2 over square root of 2, what is square root of 2 over square root of 2? What's any number divided by itself? Yeah, it's just 1. Absolutely excellent, David. It's just 1. So all I'm doing is multiplying times 1. Multiplying times 1 is never going to change my problem, right? It's just going to make it look different. So the idea here is that I'm making it look different so it's easier for me. I'm getting a more useful version of this. So you may remember this from Algebra 2. We're going to multiply times square root of 3 over square root of 3, like so. So I would have 4 root 3 over 3. This is a more simple, right? Not simple in terms of how many numbers I have to write, but simple in terms of actually doing the mathematics. This is a simpler version of this problem, right? Same thing for this type of problem. I could do, I'm going to show you something here, but there's an easier way. I could do square root of 4 over square root of 4. I'd get square root of 12 over 4, but then I would have to simplify. I would say, okay, square root of 4 is 4 times 3, so that would be 2 root 3 over 4, but now I have to simplify this into 1 over 2. So I would have root 3 over 2. This would be my solution here. What is an easier way? Notice what's the square root of 4? What's the square root of 4 here? 2, right? So can I just say, okay, instead of square root 4, let's just put a 2 there? My answer is square root 3 over 2. Check it. Same thing, right? Same thing I'm looking at here. So since this is an easier way, keep an eye out for anything that is already a perfect square, or if you can simplify it, as Ms. Yamanaka showed us on the last one, it can be easier if you simplify at the beginning rather than just at the end. Absolutely. Okay, the last one I want to show us is this one here. I actually want you to write this one down. I'm going to go 2 minutes over time today. Thank you for allowing it. Okay, we have 2 over square root of 2 plus 1. What I want to show you is if you want to simplify square root of 2 plus 1, what I need to do is multiply by what's called the conjugate. The conjugate is the same numbers, but if this says addition, we're going to have subtraction as our conjugate. So I need to multiply root 2 plus 1 times root 2 minus 1. That means I also need to multiply the top, root 2 minus 1. So if I'm thinking about my numerator here, 2 times root 2 would be 2 root 2. 2 times negative 1 would be minus 2. That is my numerator. My denominator, right? If you're fairly comfortable with the box, you can use the box. I'm sure some of us are starting to be able to do this in our heads. Feel free to keep doing that. For the sake of demonstration, I'm going to use this box here. Root 2 times root 2 gives me 2. Root 2 times 1 gives me 1 root 2. Negative 1 times root 2, negative root 2. And negative 1 times positive 1 is negative 1. My like terms here, I have 2 times negative 1. I'm sorry, 2 plus negative 1. I have negative root 2 and positive root 2. Notice negative root 2 and positive root 2, what's going to happen here? They're going to cancel. They're going to cancel because I have a positive 1 and a negative 1. They're subtracting. You're going to make 0, right? I'll make 0. And then 2 minus 1 would be 1, right? My denominator here is going to be 1. All of this, binomial times binomial, boils down to the number 1, right? When we use the conjugate, it's spelled like this. When we use a conjugate, we are always going to end up with a whole number. That's the purpose. If this doesn't cancel, we did something wrong, right? So we're always going to end up with a whole number because the middle terms, right, the negative version and the positive version will always cancel each other out, right? So the conjugate will always cancel. That means here I have my numerator being divided by 1. I don't need to note that it's being divided by 1. So I would just have 2 root 2 minus 2 as my answer here. I know that last piece was more, we should have had more time to go with our last piece. And I know I am my 2 minutes over that I promised. So what I'm going to do here, if you're feeling comfy with conjugate, I do want you to keep trying it, right? It's also not a huge portion of our problems. Most of our problems on the assignment are in the multiplying section, right? You're not doing all 12, you're choosing 10 of them, right? My expectation is that part 1 you are able to do. You should be good to go on part 1 based on our notes today, based on how comfy we were feeling earlier. If you're on part 2, there are 6 problems. I want you to choose 5 of them, right? If they are feeling too hard and you're like, I don't get this at all, I am okay with you skipping part 2. I want you to show me some type of thinking in this box, right? If you're not perfectly getting 5 problems, that is totally okay. You're still welcome to message me if you need to, or if you want to, that is totally fine. I want you to show me some type of thinking here, but you will not lose points if you're not able to correctly complete these. We'll give more time to this on Thursday so we can make sure that we've got this one. Okay. And then you have your feedback there. So there's not a checkout quiz or anything. So you should be pretty good. So these, I'm going to expect these are done. 10 problems done here. For these ones here, I'm expecting to see good thinking. I'm not expecting to see correct answers. Sound good? All right, friends. I apologize for going over a little bit. If you have any questions, send me a message. Otherwise, we are done for today, and I will see you on Thursday. Bye, y'all. Adios, adios. Bye, Diana. Bye, Caitlin. Bye, Miriam. Bye. You're welcome, Christine. Bye. Bye, Ale. You're welcome. Bye, Walter. You're welcome. Bye, Cat Cat. Brandon, David. Bye, David. Thank you. Bye, Gali. Have a great day. Mia, did you have a question?
Yeah. Okay. So for my assignment for last week, the assignment 18, I saw that you put the comment about part 2. I didn't see that part when I was doing the assignment. I think I did skip over it, but I did finish it right now, so I resubmitted the assignment.
Amazing. Awesome. So you resubmitted on Canvas?
Yeah, I resubmitted on Canvas already.
Okay. I have to go back and regrade a few people from this morning that like inputted and stuff. So I'll do it at some point today. Okay.
Okay. Thank you, Miss.
You're
Hope you have
welcome.
a good day.
You too. See you later.
Okay. Bye.
Bye. All
Your
right.
class is done. Congrats.
Woo.